In this video clip, we're going to explore the concept of isotopes. Now, isotopes are atoms that have the same number of protons in the nucleus. So that means they are atoms of the same element, but they have different numbers of neutrons in the nucleus. So that means that albeit that they have the same number of protons, they have the same atomic number, their mass number will be different. So the simplest example of this is the isotopes of hydrogen. Now, hydrogen has three main isotopes, and they are as follows. The standard hydrogen as we know it, so this would be atomic number 1 and 1. So what this means is that the number of protons, if I can open it up here, the number of protons is 1, and therefore the number of electrons is 1. Isotopes has got nothing to do with ions. This is to do with not with differences in electrons like in ions, but rather difference of neutrons in the nucleus. So this particular form of hydrogen is the one that we find on the periodic table. It's got an atomic number its atomic number is 1. Its atomic number, or its proton number, is 1. And because atoms are neutral, the amount of electrons and protons is the same, and the number of the mass number here, the mass number, is also 1. Now the number of neutrons is the mass number, which is 1, minus the proton number, which is 1, which is 0. So this form of hydrogen has got no neutrons in the nucleus, and this is the standard isotope that we find in nature. The next isotope is known as deuterium, and it's scarcer in nature than what the standard hydrogen, or what they call protium, is called. So this hydrogen isotope we could represent as follows. We could represent it as hydrogen 1. Proton number will be the same, but now if you look here in the diagram, we see that the nucleus has got two nucleons. It's got a proton. This is a proton. So protons, and it's got a neutron. So this form of hydrogen has got a mass number of 2, so its number of neutrons would be 2 minus 1. Neutrons would be 2 minus 1, which is 1, and this one has got 1 proton. But it's this that makes it hydrogen. The number of protons determines the type of element. And then a very unusual and unstable form of hydrogen is what they call tritium. Now tritium could be represented as follows. Its atomic number would be 1. But now how many particles does it have in the nucleus? Well, it has 3. So therefore this would have a mass number of 3. And we can see it that the number of neutrons would be 2, 3 minus 1, which is 2, 1 being the atomic number. We can see here that the atomic number is 1, number of electrons is 1. So another way of representing these three isotopes is as follows. We use the name and then a hyphen with the mass number. So we could call this isotope hydrogen 1 because the main form of hydrogen has a mass number of 1. In other words, just made up of 1 proton in the nucleus and 1 electron. Deuterium we could refer to as hydrogen 2 because it's got a mass number of 2, And then tritium we could refer to as being hydrogen hyphen 3. So we just say hydrogen 3. And setting up a table, we can see the number of protons is 1 in each case. So this is because this is hydrogen. But what differs is the number of neutrons. So here the mass number is changing. And so going back to the definition that we referred to in the beginning, isotopes are atoms that have the same number, of protons in the nucleus, but they have different numbers of neutrons in the nucleus. And in particular, when it comes to radioactivity, where we have nuclei that split in order to produce lighter nuclei, and they release energy and radiation, we come across what they call radioactive isotopes. And radioactive isotopes tend to be heavier than the more stable isotopes. And if we look at this particular example, tritium and deuterium are unstable. So the stable form of hydrogen is this. These forms of hydrogen can be used to produce nuclear energy. The next example of isotopes we're going to look at is that of carbon. Now, carbon is a common element that we find in many living organisms, including plants and trees. But the carbon that we've been dealing with thus far in this syllabus has been carbon, what we call carbon 12. It's this one here. And if you look on our periodic tables, you look on your card for carbon, you'll see it as 6 carbon 12, which means that it has got 6 protons. It's got 6 electrons because it's an atom, so it's got to be neutral. So the amount of protons and electrons need to be the same. And the number of neutrons, the mass number is 12. So the number of neutrons is the mass number minus the proton number or the atomic number, and that is 6. So it's 6, 6, 6. 6 protons, 6 neutrons, 6 electrons. Now, there's a form of carbon which is known as carbon 14. Now, carbon 14 is also carbon. It's still C6, but it's very, very rare. So on our normal periodic table, we don't see carbon 6, carbon 14, because there's very little of it in nature. But it's very important because it's radioactive, and it has special properties that enable us to date very old artifacts. So carbon 14 dating relies on the fact that carbon 14 is unstable, and you can see up here that it's got a bigger nucleus than carbon 12 because it's got an extra two neutrons. See, 14 minus 6 gives us 8 neutrons. But because of the fact that it's got those extra 2 neutrons, this particular nucleus is not as stable as this. So it decays, it breaks down through radioactive processes, which you'll learn about higher up in grade 10 and 11, into other substances. So carbon 14 actually, it decays into a form of nitrogen. So we are using it as an example of an isotope, but it's a very, very important isotope. So notice here, both atoms will have 6 protons because they're carbon, but their neutrons differ, and therefore they are isotopes. So isotopes are very important in physics, in particular with nuclear physics. And if you get to grade 11, you have the opportunity to do a nuclear physics research project, and there you will look at different types of decay, alpha decay, beta decay, gamma decay, and you will encounter isotopes, and you will study isotopes in more detail. But in grade 8, Basically what we're going to do is you'll be given different isotopes of the same element, and you'll be asked to identify the number of neutrons, the number of protons, and the number of electrons. And it's as simple as that.